Okay, so now we're going to define the geometric space. In the previous lecture, we defined the ordinary metric space, and then we gave an example. The only difference between the geometric space and then the ordinary metric space is that the geometric space, has three variables, and in the ordinary metric space, the metric there has only two variables. Secondly, in the ordinary metric space setting, we replace the triangle inequality with the rectangle inequality in a geometric space setting. Okay, so now let us formally define the geometric space. So here we assume that X is an empty set, and then G is a function from x to the power 3 to the set of positive real numbers, where G satisfies the following. The G distance between P, Q, and R is 0 if P is equal to Q is equal to R. And 2, the G distance between P, Q, and R is non-negative, which means basically the G distance between P, Q, and R is greater than 0 if P is not equal to Q is not equal to R. And the G distance between P, Q, and R is 0 if P is equal to Q is equal to R. Secondly, the G distance is symmetric with respect to the three variables. That is, the G distance between P, Q, and R is equal to the G distance between P, R, and Q, and so forth. And lastly, the G distance satisfies the rectangle inequality. That is, the G distance between P, Q, and R is less than or equal to the G distance between P, W, W, plus the G distance between W, Q, and R for all P, Q, R, W in X. Now let us give an example of a geometric space. So here we assume X is a set of real numbers, and then we define the function G from X to the power 3 to the set of positive real numbers by the G distance between P, R, and Q to be equal to the absolute value of P minus R plus the absolute value of P minus Q plus the absolute value of R minus Q for all P, Q, R in X. Then we can see that X is a geometric space. First of all, because the absolute value is always non-negative, the three terms, that is the absolute value of P minus R plus the absolute value of P minus Q plus the absolute value of R minus Q, is always going to be greater than 0, unless you have P equals R equals Q. And then, secondly, we can see that because the absolute value of P minus R is the same as the absolute value of R minus P, the absolute value of P minus Q is the same as the absolute value of Q minus P, and the absolute value of R minus Q is the same as the absolute value of Q minus R. The G distance is symmetric with respect to the three variables P, R, and Q. And then finally, we can show the last property by basically using the rectangle inequality as we did in the ordinary metric space setting, where we use the triangle inequality.